It is an honor and pleasure for me to speak as someone who continues with the discussion of this morning. So I will speak about the current situation in Slovenia. I will speak about a number of energy sources, not all of them. So what is crucial? The crucial capacity of technology is energy conversion into electric energy, but a balance needs to be stricken between the generated and used electric energy, not only in seconds but in milliseconds. Otherwise, we will find ourselves in trouble. So, sustainable balance is of crucial importance. We also speak about energy storage. So, how do renewable energy sources influence the development of energy sector in Slovenia? Small hydropower plants first. We know what is the structure and the characteristics of hydropower plants. Mainly, small-scale power plants are constructed on torrential waters who dry out in summer or when there is no rain. Wind turbines. The wind blowing in Slovenia is less intense than on the coast of the Northern Sea, for instance. The potential on the average is lower. The direction of the wind blowing is not the same. It is very uneven, very unstable. So we can't say that in Slovenia we have a noble or rich wind source. And if we take into account this equation, P equals F V on the third power, we see that if the power of wind falls by 2, we will only be able to generate 1/8 of energy. Biogas, this conversion again requires a base load energy. Installations cover very huge surfaces, surfaces that could be devoted to the production of foodstuffs. They require high financial backing and they are not environmentally friendly. We have seen the responses of the local communities, how unfavorable they were towards biogas. Cogeneration, electricity is more or less a collateral in the process. The heat generation is the main aim, and the power and time of performance depend on the thermal process, and it very much depends on the season. Accumulation, so small scale and large scale power plants, this is the only source that is more or less adaptable in Slovenia. We have run-of-the-river hydroelectric power plants and large-scale power plants. So, in terms of macroeconomic aspects, hydropower plants are the most acceptable, but it is very difficult to bring them to life because of the environmental concerns. So, in 2012, what comparisons can be drawn? We started to build up Brežice. We were supposed to generate 150 gigawatt hours per year. And the capacity or investment was evaluated to 120 million euros. But the final price was 200 to 300 million euros. And the interesting thing is that we still don't know the exact figure. What about solar power plants? It is very difficult to draw a predictable diagram of production capacity, also in terms of season. Own price is very high, and then there are additional costs for the distribution network, and this is something we keep forgetting. There are additional costs generated by systemic services, and the economy loses one part of its competitiveness because of the social problems that are drawn from these solutions. From the point of view of macroeconomics, such solutions are not very good because the majority of funds go for the constructions abroad, and we can speak about very high figures here. Until the end of 2012, the situation was as follows. Here we see that small capacity, low capacity hydropower plants have not experienced a huge growth. Biomass the same, biogas a slightly higher growth. There are hardly any turbines, but we see that there is a high increase in the number of solar power plants, and cogeneration capacities also grew. Solar power plants experienced a dream development, so to speak, also because this energy section was very successful abroad. We often emulate solutions from abroad, even though these solutions may not always be the optimum ones for Slovenia. There were a number of subsidies available, and the investment players responded in a very eruptive manner. Of course, the regulators lagged behind and did not harmonize the whole process. And because of the price dynamics was difficult, it was also not very easily predictable. And you know that the price of PV modules fell gradually over the time. I have mentioned the block diagram, and we see how we operate. We set ourselves a certain amount of goals or a desirable value. For instance, secure energy supply, affordable energy, and we want to follow the goals set by the European Union. These are input data. Then the regulator sets a regulatory framework, which is normal. The regulator opens the door, so to speak, and the government is obliged to think about financial constraints. These incentives cannot continue ad infinitum, because otherwise we would have 3 times as many investors as we have now. What are the outcomes? All the stakeholders are summarized in this frame, and in the end we have to see what is the final outcome. So, are the regulatory frameworks adequate? The outcomes should prove that, and the outcome should prove it now. Otherwise, we experience a fluctuation, an oscillation of the investment circle. Perhaps you will agree with me that this investment circle indeed did experience some kind of oscillation. Investment costs had an incredible dynamics. From 5,000 in 2006, they fell to 1,776. Considering such dynamics, it is very difficult to set adequate frameworks in order to achieve the competitiveness between individual players in the field of energy generation based on photovoltaics. Is such a competitiveness possible or not? And if not, then it is not very sensible to make any kind of measurements in the end. Here we see a graph for biomass in red, hydropower plants in blue, and solar panels in yellow. You can see this huge growth that really experienced a very huge support. What are the discrepancies now? You see that the power of inbuilt systems and the timeline show a very interesting picture. This is the action plan. This line shows the reference according to NEP, and as soon as a business system experiences such an explosion, then we must think about what is wrong. We want to see a much more continued flow. So subsidies are something that I will not tackle, but I think we are heading towards the right direction. The government is responding in the adequate way, but perhaps a bit too slowly. Cost per production unit. So here you see the figures for photovoltaic cells. The highest cost here is the investment cost, and then maintenance and operation costs. Of course, for the time being, we don't have to pay for the sun energy. Whereas here on the right-hand side, we see the cost for CO2 emissions. Whereas this next slide is even more telling. It tells you the calculated price per megawatt hour. So the price in euro per megawatt hour today. The data are recent, collected until the 30th of July 2013. So I will not go into detail, but I would like to just point out that our price will probably be much lower than the one on this slide. So we will not speak about the guaranteed power of renewable sources. Such energy cannot be stored in general, and the classic energy sources need to adapt themselves to the renewable sources, which means that classical resources are not used in the most efficient way. Here we can see two curves, the planned curve and the changes in the system that occurred and that need to be compensated with sufficient means. Deviations are possible. And now the conclusions, in order to avoid annoying our organizers. So renewables are expensive and they reduce the competitiveness of our economy. We can speak about that further, but I think the argument is very clear. The renewables also reduce the available funds for the development of the grid, even though a general requirement is that the grid needs to adapt itself. So we will have to take into account not only the grid in general, but the technical support, information technology, everything to help us increase the energy usage efficiency. And also we need to have a 100% backup in classic energy sources. But we need to bear in mind that by opening space to renewables, we reduce the space available to the classic energy sources. And my final conclusion would be that we need to prevent further reductions of classical energy generation units, because if we don't do that, the whole system will collapse We need to create the National Energy Program, or rather the concept, Mr. State Secretary. Things will need to be put down in writing, and they will have to be conceived in such a way that they will give the right direction. And first, we need to complete the construction of large-scale power plants, large capacity power plants. We need to complete that. All the goals would be achieved in this way, macroeconomic goals, just as Mr. Kryžanić said. So much on my behalf. Thank you.